To avoid reseeding noise on a line art grease pencil when the camera is moving, use a custom camera as the geometry processor and parent that camera to a mesh triangle. Using simulation nodes, snap the position and rotation of the triangle to the active camera using the modulo of the scene frame compared to 0 as a selection on the set position nodes. Quick answers at the beginning, but stick around for the full tutorial because you might just learn something new. Here we go! Hello all! Recently I had to find a solution to an issue with Grease Pencil's noise modifier when using the line art modifier. To demonstrate, I have this model of a woolly mammoth from the Smithsonian Museum, thank you to them, that I have decimated and made the target of a line art modifier on a Grease Pencil object. If I add a deform noise modifier, it behaves as expected. The noise changes every 6 frames according to the step value in the randomized submenu. However, watch what happens when the camera moves. All of a sudden, it starts randomizing every frame, ignoring the step value. The reason for this behavior, as best I understand it, is that for every frame, the line art modifier is drawing lines onto the geometry from the perspective of our camera. Each frame the camera moves, the lines must necessarily be different. This changes the underlying geometry, which means visually similar lines may no longer have the same seed for the random noise. You will notice the same issue does not affect lines drawn manually. These have consistent geometry frame to frame independent of the camera, so no problem. How then do we solve our line art issue? In the line art modifier under the geometry processing menu, we have an option called custom camera. This will allow us to use a different camera object to draw the lines. Let's add in a new camera and target it as the custom camera. Let's name it for clarity, camera draw. If we move our new draw camera into roughly the same location and rotation as our active camera, we can see the lines come back as we would expect. Playing the animation now shows our problem is solved. The noise modifier no longer reseeds as our active camera moves. However, we now have a new problem. If we change our viewing angle too much, the lines don't make sense anymore. Here we're missing part of the tusk and left foreleg. These are the parts that were occluded in the original camera angle. I'll enable and disable the custom camera to show the difference. So how do we solve this? We need our draw camera to copy the location and rotation of our active camera, but every time it moves, the noise will change. If we can somehow only move the draw camera whenever our noise would otherwise change, here that's once every 6 frames, we won't be able to tell the difference between a camera move reseed and a step reseed. And we can do this with geometry nodes. Let's reset the transforms on our draw camera with Alt-G and Alt-R, and open up a geometry node editor window. However, we cannot add a new geometry nodes modifier because we cannot add modifiers to cameras. So instead, let's add in a plane. In edit mode, rotate the plane by 90 degrees, merge the top 2 vertices at center using M, and move the resulting vertex to the world origin. Then I'll bring these 2 vertices in as well, just because I think it looks good. The actual positioning of these vertices is irrelevant, it only matters that there are 3 of them. Why do we have 3? Because that is the minimum number you need to describe rotation in 3D space, and any more will cause problems. Select all with A, control-click on our draw camera, and press Control-P to parent the camera to the triangle's vertices. We can now move around our vertices and we're controlling our camera. Since we're using mesh data as the parent of the camera, we are now in the domain of geometry nodes. With our plane selected and, named for clarity, stepped parent, let's add in a new geometry nodes modifier. We can drag our active camera from the outliner straight into the editor window to automatically set up an object info node. Very useful. Let's add in a set position node and plug the location of our active camera into the offset. And just like that, our draw camera is following our active camera around. Great, that's step 1. We also need to do the same for the rotation. Let's bring in a second set position node, and we're going to use a vector rotate node. This looks big and scary, but don't worry, it will make perfect sense in a second. Let's change this axis angle to Euler. You will see the rotation values are the exact same as we have in our item menu. Plug in a position node as our input vector because we are rotating the positions of our vertices. And let's go ahead and plug the result into the position socket of our set position node. Nothing has changed. Now if we change our rotation, we'll see it's going off into the distance. Well, that is because the rotation is currently centered around our object's original origin. If I keep increasing the Z rotation, you'll see it's making a perfect circle around 0, 0, 0. So we need to tell it, instead of rotating around our original origin, we want to rotate around the origin of our active camera, which is just its location. Drag the location of our camera to the center. And now our rotation is behaving exactly as we would expect. All we need to do now is bring in the rotation information of our camera, which is again generously provided to us by the object info node. And like that, we have parented our draw camera to our active camera with geometry nodes. Hooray! But we're back at square one. It's still reseeding every frame. So we need to tell it not to change every frame, only change every so many frames. We can do this by bringing in the scene time node. Then we can add a math node set to floored modulo. A modulo operation divides the top number by the bottom number and returns the remainder. The remainder is 0 every time the top number is divisible by the bottom number. So if we add in a compare node set to equal to 0, we will get a true evaluation every time the frame count is divisible by this number. So if it's 5, it will be every time the frame is 0, 5, 10, 15, 20, 25. This is a super useful technique. However, right now we cannot just plug this into the selection socket of our set position nodes. If we do, it will bounce around between its original origin and our active camera's location. It's either evaluating nothing or the camera's location. We need some way to store the previous position frame to frame to tell our camera, once you're here, don't move. And that brings us to simulation nodes. Let's add in a simulation zone. No real simulation is going on here, we're just using the simulation zone to store data between frames. So now let's go back to the beginning of our simulation and hit play. Whoa, it's going off into the distance! Ah! This is due to the fact that we are offsetting the position. Because we have just changed to simulation nodes, it's now compounding the offset every time we move. Instead, we just need to snap the geometry to our intended position. To do this, we're going to want to use the position socket as opposed to the offset. This looks like it's working, but our rotation is gone. If we use the position socket, each of our 3 vertices is going to collapse into a single point, making rotation impossible. We need to preserve their spatial relation to each other. We can do this using a store named attribute node. Set it to vector and the point domain is correct. We're going to plug in a position node and name it something like initial position, ini_pos. Now we're going to take a named attribute node, ini_pos, and vector math set to add our initial position to the position we want it to be in. And we plug that into the position socket. We should see the behavior we want. Look at that, our problem is mostly fixed. There are just a few things we need to do first to make it really good, but that is the core of the effect. You will notice the first few frames everything is blanked out. Why is that? That's because our camera is still at world origin when it really should not be. It should already be here. And that is because our timeline starts at 1, so already our modulo is not working. We want our frame start to be at 0. Okay, but it's still not moving. That is because our simulation range is not big enough. We have to make sure in our scene settings that we tell the simulation range to start at 0. And since it is still not moving, we also have to go just delete our cache. And look at that, it starts here as expected. But while the camera is in the right place, we're still not seeing our line art. And that's because our line art actually has keyframes associated with it. It will not show up until the keyframes start. So you just have to drag these over by 1 frame, and now it should start at frame 0. Perfect. There are a few more optimizations we want to do. In our stepped parent function, we can actually drag in a new input to expose our frame step. Let's call it frame step and make it an integer and give it a default of 5. And we can also expose the object of our object info to generalize this node. So now you can parent anything to anything else in a stepped fashion just by changing this one value. One more fun optimization we can do is right-click our frame step variable and choose copy as new driver. Go into the line art noise modifier and paste the driver. Now we won't have to manually check that these two line up. We can change it here, and in the line art, it will have also changed. Well, I hope this has been helpful. If you have any questions or comments, please leave them below. I hope you have an excellent rest of your day, and I'll see you in the next one. Bye for now.